Max is an engineer who's working on digitalization and has been, the title of this talk is Connecting Undergrounds. So without much of the stage space, I'll let you talk then.
All right, thank you for the brief introduction. Yeah, my name is Maximilian Lischke. I've been working at Herrenknecht since almost 4 years now in the Department of Digitalization, which only exists for 5 years, so also a pretty new field for us when comparing to the history of our company. And yeah, today I want to talk you through about how digitalization can transform projects, how projects are executed, how projects are monitored, finally enabling smarter, safer, and faster tunneling operations. So why do we actually need digitalization now? So as we see here, like in 1985, we had smaller diameters, we had no sensors, no data acquisition, and this increased massively over the last years. For example, in 2022 here in Silvertown, we almost had 5,000 sensors acquiring data with a frequency of a second, or for some sensors also a few hundred milliseconds, which produces billions of data points over a project runtime. And to utilize this data, to gather it first of all, to manage it, then interpreting it and acting on it is basically what means digitalization for us. Comparing to that, what is the reality on most sites today? It's still a lot of paperwork, it's spreadsheets, for example, shift data management, maintenance documentation is mostly stored in Excel spreadsheets, for example. And today the lack isn't really a lack of technology, but a lack of integration of systems and usability. So putting all that together is basically our approach of digitalization, and so that it works for people in our industry. So let's have a look at our agenda for today. So first of all, we're going to have a look at the current state of digitalization, what we have done so far, what are the main points. Then from top to bottom, we'll have a look at our design process, our development process for digitized products, which puts the human in the center. Then we're going to have a look at our platform, which is called Herrenknecht Connected. We'll also talk about artificial intelligence for sure, like every day nowadays, and predictive use cases, and then end with what we've learned and an outlook into the future. So if we zoom in at the current state of digitalization, the first big challenge is fragmented data. So information is scattered. We have machine data in one place. We have maintenance documentation in one place. We have shift data logs in one place, and nothing really is connected. And additionally, there's still paper flowing around. So teams often try to find consistent information across the system and struggle with that a lot. So the result is a data puzzle where there are insights for the specific system, but nothing really is connected. And yeah, by building like a unified platform for the whole job site, we're trying to address this problem. So also a second issue we see is there's still a lot of manual workflows and inefficiency. So we have reporting or inspections, documentation, still a lot done with pen and paper. Then maybe typed into Excel, then maybe sent via email, then someone's creating a report out of that to generate insights. And each manual step produces delay and also risk of errors. So by the time a problem is reported on site, the issue could have escalated already. And digital issues can help eliminate that lag and provide real-time awareness for the problems, and also lead to quicker responses to these problems. So maybe let's do an example here. So a usual cutter head inspection, how is it often on site today? So we do the inspection, we go into the cutter head, we write it down on paper, what was the wear, which discs have we changed, put that all on a paper form. It's dirty there, the papers may be ripping apart. You can't read the numbers on the paper. Then you have to bring it up, you type it into Excel, you have to send it via email, you're reporting it. And for example, by doing that all digitally with an app directly on the cutter head, you can just directly type the values in your app on your phone. It's saved in the cloud and directly reported to the people who need to see it. Also, a common pitfall in digitalization is that assuming that more features automatically mean better tools. But in reality, complexity eliminates adoption. So some tools end up unused because they have way too many features, they are way too complex, because the interface was too complicated, and it just didn't fit into the daily work routine. So yeah, usability really is a key to fit into the projects, that people actually are using the tools and actually really help them. So technology must simplify the workflow and not complicate it. It also brings us to our design principle, which yeah, puts simplicity in the center. So we try to focus on clarity. So for example, the user instantly understands what he needs to do in the software. You don't need extensive training. It's just logical what happens. Then speed is also a great point. So you want to get your task done instantly. So you don't want to do a lot of amount of clicks. So it should just go fast. And usability should or adoption of the new software should happen naturally, and users actually want to use the system. Yeah, so basically a digital tool should feel intuitive and supportive, and not like a task that you still need to check off your agenda. So that basically brings me to the next point we want to highlight. So which is the human-centered approach of digitalization and putting humans into the center of development. So digital systems and tools should adapt to people and not the other way around. So on a job site, we have lots of different roles and lots of different workflows. So an engineer, an operator, or a manager need to do different things, and also they should use different tools to do these things. So the tools should also be designed around them. So for example, a TBM operator needs concise, actionable data so he can act upon the data, for example, adjusting the parameters of the TBM. Then maybe an engineer needs a broader view of the site, needs to have an overview, needs to see, for example, upcoming maintenance that he can plan. And for example, a manager needs insights and KPIs so he can make the right decisions for the project. And by tailoring the interface to each specific role, the adoption increases naturally. So yeah, it's basically about supporting people with digital tools rather than forcing them to change their workflow to adapt to a new software. This is also what we find in surveys. So a survey from 2021 found that 60% of employees experience frustration with new software. And this basically comes from unclear workflows, from unnecessary clicks, inconsistent interfaces. You just don't find yourself around in the system if it's not really consistent. And if a user has a bad user experience while using a system, he often reverts to old methods like paper, spreadsheets, or other tools. So this leads to fragmentation of data again, which we basically want to avoid. So the design of software needs to focus on usability before developing to deliver the right software. Which brings us to our design principles we're trying to have in mind when developing products. So first of all, it should be simple. So we want to avoid clutter. A user should only see what he needs to see to complete his task. So no complexity, just what he wants and needs to see. Then we are thinking or we're developing logically. So users should understand what comes next, what I just said earlier, without many instructions. So it just should feel naturally. The system should guide you through the workflow and basically tell you what you need to do because it just feels logical. And the role-based approach, which I just mentioned earlier. So a user only needs to see the data he needs to see, so you don't have the clutter as well. And and just sees the information that is relevant for their tasks. So if you're trying to use these principles, software can really reduce errors and speed up workflows. But to create software like this, to create visualizations and insights, we first must acquire the raw data. So raw data just for itself doesn't really bring any value. You have to put it in context, and you have to process it, you have to visualize it, and then create an insight of it. For example, if you don't need to monitor like every data point of a sensor unless the trend or the data indicates a problem. So for example, if you're looking at the torque, you don't need to look at the torque of the TBM, for example, for the whole time, but you then need to have a look at it when the trending is problematic. And so we try to process that data in this in that funnel and create insights out of the data and deliver them to the right person at the right time. So now that we've talked about a bit about the theoretical parts, I want to show you like what we have been developing in the past, like what are the benefits of digitalization for tunneling projects, and want to basically show you our platform and the use cases we are seeing there. So basically our platform, Herrenknecht Connected, is an IIoT system, which means Industrial Internet of Things. Maybe you've might heard of Internet of Things, which basically just means connecting machines with each other so that they communicate with each other. Basically our platform integrates machine data, sensors and cloud services, as well as manual input of a user. So we bring that everything together and deliver it to either a job site user or a mobile user within different applications. And And basically this data acquisition is the backbone of our platform. There seems to be a cloud missing. Oh, there it is. So when we're looking at this, we see the edge, which is basically the machine on the side. So we have all the sensors acquiring data. What we saw earlier, for bigger TBMs, it can be 5 to 4,000. For smaller machines, it's maybe less. But every machine has a data acquisition running. This data is then processed into the PLC of the machine, then transmitted via OPC, which is just communication protocol, and then transferred onto a database, but still on the machine. What really brings the benefit now is transferring that information to the cloud. So when connecting that machine to the internet, we can transfer the information, the data to the cloud and make it accessible from everywhere. Like you are used to checking the weather, for example, on your app, on your mobile, you can check it. You can check TBM data on your mobile as well, or on your tablet or on your PC. So this just puts more just gives you the most recent information all the time. So you don't need to be in the local job site network, for example. You can just retrieve it with simple internet connections. So since we're a machine manufacturer, we're not only interested in our machines, but in the holistic view of the job site. So we see tunneling projects as a big complex system, and we want to look at every process of it because everything just connects together, and everything depends on each other. For example, we have a look at the excavation tools, about the navigation and monitoring of the machines. We're looking at maintenance. We are looking at things like mug handling, integrating different systems of the job sites. For example, conveyor belts, separation treatment plants, water treatment plants, shaft boring, road headers, for example, and basically bring that into that holistic job site view. And it basically works like a toolkit, so it's modular. So you don't need every module, so you don't really get every module when you don't need it. So for example, a gripper machine, for example, doesn't need to track its segments. So that is the modular thing we try to do there. So this is basically our entry point, our customer portal. So it's a central entry point of all the platforms. So there we're bringing together all the machines, the most important information of a machine, for example, the KPIs you see there, and just use it as a navigation to bring users into the system, get them to know the system from the usability wise, and then dive deeper into what they're actually interested in. So what we're like spare parts on site are always critical. So if you don't have a spare part and you have to do maintenance and the spare part is not there, the machine just stands still, which costs a lot of money. So we are trying to put that into a digital system. So making all the documents, all the drawings available in the system, and directly making or being able to order the parts that are missing. So parts can be requested or ordered directly in the system, and also you get a full history of all orders. So you can also track it. You can see who ordered what, who you have to contact, So we basically have all the information together, and information is not scattered anymore. Before, you might have called someone at Herrenknecht if you're missing a spare part, for example, and with this you can just order it simply in your in the system. This also is linked to our content management system. So in the past, you might have gotten a big binder of documentation, of supply documentations with hundreds of pages, with machine instructions, with safety guides, and we all digitized that. So this is all available. We put that all into the system and made it searchable. So everyone can get the information he needs without needing to search for it on a PC locally, for example, in the storage, or even search it in a big binder. And also, it's all the time it's up to date, so you don't have an outdated documentation, for example. So this brings us to our main module, I would say, which is the data acquisition module, where we process and visualize all the data captured on a machine. I don't want to go into too much detail there. I'll just go quickly over it and then show some highlights. So at first we have a machine visualization, so we can look into the operator's cockpit. We have with dashboards, configurable dashboards with KPIs summarized. We have access to reports. We have access to charts with sensor data. We have access to navigation screens and maps. So you can also see where your TBM is going. And basically this is the foundation of every other module we are providing. Because the machine data basically is the backbone of the platform, and interacts with all the other modules. When speaking of a holistic job site view and dashboards, you see here that, for example, there's also the possibility to have a TBM and an STP directly visualized in one screen. So both things depend on each other, so it would also make sense to have a look at them at the same time. So you directly see where you need to act or if you don't need to act. Then we have the visualization I mentioned earlier. So basically, this is a replication of the operator's cockpit. So you see what the operator is currently seeing, not in real time, but a few minutes of delay. So you don't need to be on the machine all the time to see what the operator is doing. You can what the operator is doing, but you can you can help him. You can monitor it by yourself, and then also act upon it as an engineer in the office, for example. And it's also fully interactive, and no worries, you won't be able to steer the TBM with it from the side office, which is quite good, I think. But basically it doesn't interfere with anything what the operator is doing. Then also regarding the holistic view of the job site, I think I didn't mention it earlier, but we also try to put more focus on the geology because we think it's a big topic in tunneling. So we also integrated like long sections from the geology, and we're trying to match it with the machine data at one view. So maybe you can see correlations of upcoming issues, for example, cutter head blockages, when analyzing the machine data and also having a look at the current expected geology. I'll also go more into detail afterwards. yeah, but basically this is like an approach of us trying to match different aspects of the job site in one system. So this brings us to what we call add-ons. So on the job site, you have a lot of different processes, which you need to have a look at, and we're trying to put that together with the, we call it add-ons for the basic machine data acquisition. Yeah, so we have a shift data management, we have a maintenance documentation tool, a tool for the excavation tools, a 3D visualization, energy monitoring, geo-monitoring, and a stock management. So I will just quickly go over them one by one. So our shift data management system, ShiftOn, is basically recording all the activities on a job site. By also integrating sensor data, so this is being tracked automatically by the data or by the system, and then you can also add digitally and centrally what is happening on site, like what are your critical activities, what is causing the most downtime, and directly get an analysis available for everyone because it's just centrally stored. Then we're having a look at Toolzone, our excavation tool management, mostly important for hard rock projects. Since the excavation tools are so expensive, we try to monitor it and to track their wear. And yeah, basically what I mentioned earlier with the cutter inspection, it offers also the possibility to directly enter your wear on the TBM. If you have an internet connection, you can directly enter it there, and you can see what the wear is. And then also with machine data, with like the rotation of the cutter head, for example, with the advanced speed, you can directly calculate important KPIs for the cutting tools. Put that into context. Then we're looking at our 3D visualization. So this is also really important for segment trackings, for example. So you see a 3D visualization of your tunnel, and you get a report of all the information available for a certain ring directly in the system. So you see everything what was relevant at that point. So for example, navigation parameters for that ring. You see the deviation. You see how much pressure you had. You get all the data you've had, and can also document damages in the tunnel. So, for example, if you find a damage on a segment, you can have a look at that and see if it could be caused due to the machine, for example, of too much pressure, and then also document it in the system right away. So since sustainability is also becoming more and more important, we also try to observe that. So not only for our machines, which have high peak loads or which can have high peak loads of energy consumption, but since we also want to have that holistic view of the job site, we can also equip like other equipment with that acquisition and monitor the energy consumption of that. So you're not really interested in only the TBM, but in the information of all equipment on the job site, which can be monitored with that. So then, we'll go on with the geomonitoring system. Also showed like a bit of an integration before, but this is basically developed for geologists, for people, for geotechnical people who analyze ground conditions, who do probe boring drillings, and basically that's also a system to document all of this. So for example, we have these long sections before a project, but it's just an inspection, right? So we don't really know what you will be excavating in the tunnel. So there's also the possibility to track what you're actually getting out of the tunnel. So we try to compare it, and then also really see connect with machine data and see if the data. So also spare part management, or is in relation with the spare part management, but basically you can manage your whole stock on site. Like not only HK articles, but all articles you have on site. So you see how much of them have you used, how much you have on site, if you need to reorder something, and just put together everything in one place, in one platform. And also this can be like the foundation, for example, for maintenance. So that, for example, if you have an upcoming maintenance, you don't have the tool ready or don't have the spare part ready, you can directly see that in the system and reorder it in the same system. So you don't even need to leave the system. You have all the information together and can just order that part if you don't have it available. So let's do a bit of a deep dive into digital maintenance management. So basically maintenance, is, or here digitalization can demonstrate how the tool can demonstrate how digitalization can simplify like really complex workflows while still being human-centered, what we've discussed before. So we have different roles also for maintenance management. We have mechanics, we have supervisors, we have engineers, and everyone is interested in the in doing the maintenance, but want to have different outcomes, different insights about it. So we're also looking at current challenges about maintenance. So on a lot of job sites, we still have this paper-based, Excel-based documentation. Sometimes you need to print it out. You need to hand it to your mechanics, tell them what to do. It's also not really sustainable, and the information can be lost because it's just paper. If you're not careful and you lose it, then it will just be gone. And with our approach of human-centered design, we try to do an application based on these user roles. So for example, a mechanic, he performs the maintenance, he wants to see documents, he wants to report issues he sees on the machine on site. And we have the supervisor who can resolve issues, who can review pending and completed maintenance, for example. And we have the manager or engineer who manages, for example, the site assets and plans maintenance ahead. So we're trying to build build the software from this perspective. So first of all, we have the asset management. So first of all, before you can do maintenance, you need to know what assets do I have on site, what do I need to maintain. So that's also putting this holistic view into the system, because we cannot only display our machines with our maintenance tasks, but also all other machines on the job site, because you just want to have it in one place. So then we have the preventive maintenance. So basically, maintenance is always based on either time-based intervals or usage-based intervals. And here in this case, we have structured it. So a task can have an assembly group. It can have a component. So historically seen, you can track every component. So you see if a component breaks down, you can retrieve a history of that certain component and see, was it maintained well? Was maintenance not done at some point? Were there any issues? And you can just track it down because you have the full history of it. Also speaking of integration of sensor data, for example, if you have a task after, like you need to do after, for example, 1,000 operating hours, you have to check all the time have to check, when do I have this 1,000 hours? You have to check the sensor readings. You maybe have to document somewhere to maybe also do kind of a prediction. But with integrating the sensors from our machine, we can just notify, we can trigger that task when it's due. So you get the right information at the right time. And also pretty important for this is attaching pictures and documents right to where it's needed. So due to our documentation management, you can put, for example, the supplier documentation directly to the task that is referring to it, and you don't need to search 700 pages of a supplier documentations to just find the one page you're actually interested in. So then after a task is due, it also has to be done. If there are no issues, that's good, you can just complete it. But sometimes there occur issues, you don't have a spare part, for example, something breaks down, something else gets more important. And basically, we just implemented a way of communicating directly on that task then. For example, you can set it to different states and set it or comment on that, so supervisors know that a problem was detected during that task, and you can also directly resolve it. For example, if a mechanic reports a problem with a task, and you're, for example, in the site office, you can just get or you just see that someone commented it, and you can directly respond to it, taking action and telling what needs to be done. Yeah, this directly takes us to like corrective maintenance. Like in the system, we differentiate between preventive and corrective maintenance. Sometimes components break down, and yeah, this can also be tracked down here in the software directly. Pictures can be attached. You can use the same structure of the assembly groups and the components. So you, in the end, get a full history of a component, either of preventive maintenance or corrective maintenance, and have everything, everything combined. Yeah, since maintenance is basically done on the field and documented on the field, we thought it would be useful to being able to do that in a mobile way, so that you don't need to fill out, like we discussed before, paper-based forms, then transfer it to Excel, then send it as an email or store it somewhere else. But for example, you can just document everything in a mobile or tablet app. Do your tasks there. You have all the documentation on the tablet. You have all pictures attached. You have all the drawings you need, and everything is just stored centrally, and everyone gets the information he needs. All right. So let's have a look at our agenda. That was our platform, like what is the current state now. And now we want to look a bit further into the future. I think AI is everywhere today. There's new AI tools coming out every 2 days, if not every day. And you don't really, as a normal person, you can't really to have that pace to track it. But I think it can be pretty useful, and for sure also in tunneling operations. Yeah, so I think that this basically refers pretty good to what Asil said before. And I just want to highlight what AI or artificial intelligence means for us. So for us, it's not replacing humans, but also AI supports human decisions. So it just gives you the right information, so you can make an informed decision by yourself and not letting AI tell you what to do. So for us, AI basically means identifying patterns in a large data set. Before we saw that we have billions of data points collected over a project runtime, and basically it's impossible to analyze that all by yourself, like manually. So therefore, we really can use artificial intelligence in that case to see unusual behavior, for example, in a TBM operation. So basically, this is the data flow that we see from data to prediction. So data is the backbone again. We can do analysis on the data. We can uncover trends, correlations, anomalies. We then can, from that, predict future events or estimate future events, what could happen, for example, the wear of a specific component, or potential downtime. And then we can take action on what was predicted. And when we find that the action was not right, or we have to feed it back to the data to actually, so that the system actually learns what it did wrong, so it can make better predictions in the future. And so we're getting that continuous loop of feedback, of learning and improvement, which basically is machine learning in that sense, if you've ever heard of that, which is just a smaller part of AI in general. So speaking of anomaly detection, we just tried it for ourselves a bit to see what we can actually do with the data. So basically, an anomaly detection highlights deviations from an expected behavior. For example, here we had a look at the gearbox, and we found that the frequency converters were not really running right. And we just could discover that because we know we had a gearbox damage at some point, and then just had a look at the data, had a look what was the data like at that point before the breakdown, and we analyze that pattern to be able to predict such events in the future. So we can basically intervene before an issue escalates. So chatbots are also everywhere nowadays, also in our minds. But here I want to highlight that AI always needs context. So if you ask ChatGPT, for example, for the weather today, it will give you a pretty good response because it has all the information from the internet from today. But such a system doesn't really know the processes on the job site, on the tunneling job site, the underlying data of the TBM, for example, and doesn't include all the information it basically would need to make a decision or support the user. So in our sense, it's more like finding information more quickly. We're also going into the direction of including all the documents, for example. So basically having a AI-based search tool, and also ask for sensor data. So you don't have to really search through the charts, see where a peak was, for example, of a sensor, but you can just ask chatbot and get to your information way quicker than having to search it manually. Yeah, data quality and context. So to be able to make reliable predictions, we need to contextualize the data. So AI predictions are only as good as the data feeding them. So raw sensor data is basically just numbers. It doesn't really tell you much. So you need to structure it and put it into context. For example, yeah, what is about, what are related sensors maybe, what is related data. And only if that data is good, is standardized and clean, AI can really deliver trustworthy insights. All right, then let's have a look at what we've discussed so far. Yeah, we've talked about digitalization in general at the current state. We've had a look at our platform, like our sense of digitalization, at AI, and yeah, now we'll bring everything together. So what we learned, digitalization isn't just about the software, but it's way more. It's about, first of all, about the people. So what we learned, users need to adopt to new tools. They actually need to use it, and they also have to produce good data. For example, if you put in just random numbers into a system, you won't get anything out of it. So you basically also, as a user, need to be interested to really put in the work and put in that and feed the system basically with data so it can act upon the data. Then we're also looking at processes. So I think a big step there was the unified platform, so integrating all equipment on site. So for example, the TBM, the separation treatment plants, the conveyor belts, like everything what is on site, have the same data acquisition, and and put that all into context. And it's also about the technology, sure, which basically refers to the tools that are used, that they are reliable, that they are accessible and connected with each other. So we see that integration and standardization matter. Like platforms like this can connect multiple domains, like maintenance, what we saw, like shift data management, logistics, energy, geology, whatever is important for the project to really avoid data silos and make everything work together. This just again highlights our holistic view of a tunneling project, which I think we need to really utilize digitalization. So talking about connected systems, basically, like I said before, all the processes somehow depend on each other or relate to each other. For example, that's like an example of a human-machine interface. Like what could be running on a potential future TBM. So it basically matches. It has the machine data. It has information on the cutting tools. So it could tell you what disks needs to be changed, which disks are, for example, not turning anymore, and it also gives you like the geotechnical parameters. For example, it tells you in which geology you're currently in, what are the geotechnics behind it. So bring everything together, and then being able to utilize the data and create an insight or make a decision based on that. So let's look at the road, what's upcoming. So what we saw now, we have connected systems, we have a unified platform connecting machines, applications, and sensors. So we're trying to bring everything together to just have the data as a foundation. So we really can also have a look at historic projects and do predictive insights based on that. Because if we don't have the underlying data, we cannot really try, or it doesn't make sense to try to predict anything just based off, for example, one project. So having all the data available, really is an enabler for predictive use cases and artificial intelligence in the future. And what is coming later, I call it later here. For sure, there will be at some point maybe an autonomous TBM, but I think that's in the far future. But what will come after that, in our opinion, is prescriptive assistance. So not only that the system is telling you what is happening right now, what maybe isn't working right now, but to also suggest what needs to be done. So adjusting, for example, TBM parameters, by itself without any interference, just because we have the underlying data of it. And I think that would make digitalization like a real partner for tunneling projects, supporting people rather than replacing them.
Hello, brilliant presentation, Max. Before we move on to questions, I think I'll take the lead and start on this because it's a topic which I really like. You mentioned AI is only as good as the data it feeds, but there's another component in this which you also alluded to, which is a human-machine interaction. And it's a full set. One of the major problems we have identified with the current set of GPTs, which is generative pre-trained transformers, is that the output from them is only as good as the questions we ask. And if we don't ask correct questions, then the loop isn't created and it leads to hallucinations. So just to set the ball rolling, in your approach of human-centered systems, have you accounted for this human-machine interactions through questions?
Yeah, you're totally right in that, but I think you have to really differentiate a bit between what is prompting and what is the underlying databases, because your prompt can be as good as you want. If the model doesn't have the underlying data, it cannot give you a concise answer because it just doesn't, it's not included in the model. You write like a whole page of the prompt, but there's nothing behind it. You also won't get a real good answer. So basically you need both. You need to really describe what you want from the system, but also it needs to have the data it can refer to give you that answer.
Thank you. Now I open the floor for questions.
Thanks, Max. Great presentation. In your architecture of your IoT system, you showed that the data transfer happens on the cloud between different users. I wanted to ask what happens if there's a downtime with the cloud provider, or do you have any resiliency or fallback mechanism if that happens, so the user could sell the data in real time?
Yeah, we're trying to use redundant systems, and also trying to have to have a look at different regions because we're our TBMs are everywhere in the world, and so we try to really distribute the load of the system all over the world, so that we can host, for example, host the data in a different country, like where the TBM is currently operating, and making that a redundant database.
Thank you.
Also, people online, feel free to ask questions in Q&A and put it in the chat if needed.
Yeah, thank you for the presentation, Max. A question on the data accessibility and availability. So is that the database, is that only accessible through the magic Herrenknecht interface? Or is that a standardized data format which can be, in theory, be live accessed from with my own tools, which I program, for example?
Yes. So on this one slide, I had the word REST API. I didn't really want to go into too much detail about that, but basically this is how we're transferring data from the machine to the cloud. And basically this can be whatever cloud it needs to be. It doesn't need to be the Herrenknecht cloud. It can also be a different cloud. So it's just the interface which can be used to also get that data into other systems, but you will get the standardized contextual data. Yeah.
To add on to that, pretty much every client you buy these days, if it collects data, it will store using OPC protocol. So there's always the option to transfer data from one server to another as and when required in real time.
Because one thing I will tell you, that is there are several contractors operating in the United Kingdom do not use the Herrenknecht database. They have their own systems that analyze the data that Max was talking about in the way they wish to process it.
There are also some industry participators which are quite keen to lock the data they're generating away and provide fundamentally lock you into a subscription model to access the data later on. So that's basically that. Hence the question. Thank you.
Yeah, we don't use that. We're not like that. You want that Chinese?
Keep me honest, my friend.
Yes. The one I'll ask you is this. Mostly you say fairly obviously Herrenknecht can't take control of your automated machine or start the cutting head. Can it be used as a diagnosis tool? And do you see it being used as a diagnosis tool for fault finding when the AI gets better?
Yeah, sure. Like this is what I mentioned with the underlying data before. So what we are just trying right now is basically to predict the wear of cutters, for example, with the underlying data. but using it as a, like we want to transfer the use case like from a historic view, like to have a look at the data if already something broke down, if there was already an issue and you have a look at it, to doing that prognosis. And I think this is what really is the benefit of digitalization of the data. So you can then change your disk, for example, before it exceeds its wear, for example.
So how far away are you from me being able to go and from saying, tell me which around or which sensors were showing a weird reading during say advanced number 217, rather than me having to toggle off each sensor and think of a sensor that I should be looking at and toggle them off.
Yeah, we're currently testing that. So that was our first like hypothesis while developing it. So what do users actually want to do? Like what is our most used feature now, which is like the visualization and the charts. And yeah, basically we're trying to take one of these use cases and apply AI on that. So that is a use case we had also had in mind at first, and we're currently testing that, so that is already possible.
One question.
Not easy. When you're there trying to figure out what went wrong and you have to go through about 100 sensors
Yes,
and toggle them on and off, it just sometimes gets a bit too much, especially if it's in the middle of the night.
that's true. Yeah.
I'll take one question from online audience. So this is regarding your GeoOn app. Philippa has asked, can you give further details of what you can record on the GeoOn app, and how far in advance in terms of meterage can AI identify high risk areas such as fault zones, and yeah, in terms of geology, groundwater risk like rock strength, rock weathering, grade faults, and groundwater ingress and water pressures.
Yeah. Yeah. Maybe let's answer that second part of the question first. Regarding that, like in our department, we also have like a real data science team who's looking at these use cases. And this is for sure a thing we're having a look at, but it's nothing we're able to provide in the nearer future, I would say. So we have done tests, but as I said before, the outcome you will get is only as good as the data you have. So that's why we also started this GeoOn application to really collect that data from projects to see what did I really get out, like which material, which geology did I really get out, what was the machine data at that point, and then you can have a look at that data and make predictions to that geology you maybe will be having. So basically this GeoOn acts as an enabler for these geology predictions. And what you can do with the GeoOn is basically, I think what is the most common use case is that comparison. What was I expecting and what am I getting out? And then also put like these geotechnical parameters like UCS or like the abrasivity into context with machine data to really enable that predictive use cases.
Thank you.
I have one following that GeoOn. So, do you need a database before the TBM starts excavating with the geology of the site to get the data of the geology after, or you just give general data from the TBM? Do you know what I mean?
Yeah, like
You need to feed the information to the TBM to get the data for that formation, or you get general data.
Yeah, I mean, when talking about encountered geology,
Yes.
you can track that with like in sections. So we can specify we had this geology for 200 meters for that chainage, and then we had this for the other one, then we had a combination. and all of our sensors are also referring to the chainage or to the time. So we know at which point in time we've had which chainage. So it just matches if you put in the right numbers. That's what I try to say. Like if you have this data, you really need to maintain good quality data to be able to get these use cases in the end. And yeah, before the project is starting, for the expected geology, we need to somehow digitize that. So this is also something which I've seen quite frequently in site offices, a huge geology on the wall, but no really interaction with machine data. Yes.
Max, you talked about the road ahead, so that's a sort of driving analogy. What about being an astrologer and predicting the future beyond what you talked about? So you've talked about connected systems, which you have now, and then predictive systems, either insights or assisted. What about automation? How much automation could you see in the future?
Yeah.
Partial or full?
I don't think I want to have a take on that, to be honest. But
We'll have a go.
We're already trying to automate different parts of the TBM. So, for example, automatic erector, automatic steering of the TBM. Yeah, I'm not too much into that, to be honest. But saying a number is difficult to the fully autonomous TBM.
Just one quick question. On the AI chatbot you showed us, is the data and the context stored by Herrenknecht, so you just self-deploy it, or are you actually sending it to OpenAI, Azure, or whoever is providing the LLM? What I'm interested is like I would not like data from my project to be shared.
Won't say.
Yeah.
It won't be.
Belongs to you.
It's good.
We know it internally to help you, but it's stored, you own it, and it goes nowhere else.
Yeah, so on your cloud, on your premise, basically.
Yes. Yeah, but no, not publicly.
Even internally, we don't share it very far.
No, that's good.
I have a follow-up question on automation and imagine, okay, you have your fully automated segment erector, and the segment erector then cracks a segment one way or another. So is it now Herrenknecht's design who is at fault, and are you paying the fee, the bill for repairing the segment? Are you suddenly a designer or not?
Won't happen.
Hopefully, yes.
It won't happen because the automated erector will have controls on the pressures, so it's less likely to happen with an automated system than when someone hasn't fisted operator.
Yeah, I hold you to that.
We'll all be involved. We'll all be involved when we have to pay up back in a huge. Just to follow up on that, most cracks, an awful lot of cracks or small damage you see on segments, it's minor faults in the detailing from the designer.
I think this
Not wishing to be. Debate for the
bar, yeah, we are heading to the territory of questions in the bar, so I'll allow one more question before this becomes the bar.
I spoke with Christoph in the bar. I'll tell you a story. Having sat there, listened to people blaming the machine, and with my background being more civil and having designed segments, well, no, there are some minor defects in the design, and the answer was, "Oh shit, it'll take us too long to get it approved."
Yeah, that's the minus answer, isn't it?
Yeah. Let's go to announcements now. Continue this in the bar. Thank you, Max.
No.
Very insightful presentation, Max. And moving further, the announcements for things coming ahead. So British Tunneling Society at 50 years of service to tunneling industry. Oh, that's a long time. Drinks are sponsored by Herrenknecht. So a round of applause for our sponsors. On third,
I think on the off Jerry, sorry, I was going to suggest, if you bump into Martin Herrenknecht, don't thank him personally. Vicky hasn't told him. No, this being recorded.
on Thursday, the 20th of November,
That's to Germany.
it is going to stay along as a record for everyone. The carbon management for metro projects Copenhagen. It will be delivered by John Mayani and Dr. Alan Thomas. John Mayani, all right, correct myself. Thursday, 11 December, we have the slip form tunneling, revolutionizing tunneling construction from Colin Eddy and Henry from CCO. And the comments are fun as well. The BTS Health and Safety course, please do register for it. The bookings will close tomorrow. It will be held on the 17th and 18th of November. So an evening social will also be held at the end of day one. Refreshments will be provided. So save the date for the BTS conference and exhibition 2026. It will be held on 6th and 7th of October. So reduced prices will be for young members and free places for students. So stay tuned for further information on this. Do order the tunneling book. Now it's £65 onwards. It has a great piece of history and it has enough weight to break your coffee table book, but it can be used for defense. Try to scan the QR code if you want to access it. Thanks for attending, and please scan the QR code to send us your feedback. And before ending, I'd like to end this with a quote from Pearl S. Buck. Since it's a young members lecture, to get the tone on, the young are not prudent enough, hence they attempt the impossible and keep on achieving it generation after generation. We'll be listening to you, but yeah, we'll be doing our own thing as well. Thank you.